Hey everybody, thanks for joining me. It's Parker from TestPrepChampions.com. This video is all about triangles and what you need to know for the GED math test. So I'm going to teach you guys things like how to name triangles, how to classify them by their length, how to classify them by their angles, and how to recognize the difference between an equilateral, isosceles, acute, scalene, and obtuse triangle, right triangles. We're going to look at all of that, some tricks to keep it all straight, and some example problems. If you're new around here and you haven't subscribed yet, please go ahead and do so. I make new videos often to help you pass the GED math test, and I don't want you to miss anything. So go ahead, hit that subscribe button, and we're going to get into the lesson. Okay, so let's get down to business here with some triangle basics. And if you're taking notes, you're going to want to add these 3 points down into your notes. So this is a triangle, what we see on the screen here, this big blue shape, and you've probably seen triangles before, okay, but if not, you'll want to, or if it's been a while, you'll want to remember what a triangle looks like. And so the first point to know about the triangle is how to name them. So you name triangles simply by listing the vertices in any order. Now, if you're like most people watching this video, you're probably wondering, well, what in the world is a vertices? So I'm going to tell you. So a vertices, simply put, in this case, it's a point where two lines meet. So we see this line here, okay? And we see this line right here, and we see that both of the lines meet at this point here. So that's all a vertex is. Okay, so what we want to do when we name the triangle is, and this is important to know for naming triangles and because you're going to probably see this written in your practice test. So we see this little triangle looking symbol, and you could name it triangle A, B, C. Okay, and how I did that was I just went around the world here. I went A, B, C. Okay, but we don't have to do it in that order. So you could also name it C, B, A. Okay, and how I got that C, B, A is you can go this way. You could go C, B, A. Okay, and lastly, you could also call it C, A, B if you want to. Doesn't really matter. You just name them by listing the vertices in any order. Okay, and so another point to know here is that when we're naming the sides of the triangle, we could call this side right here, we could call that AB, or we could call it side BA. Doesn't matter, it's the same thing either way. So with this side down here of the triangle, okay, let me trace it for you. What would we call that side? There's two options here. We could call it either side AC or CA. Doesn't matter. And the same with this side of the triangle here. We could call it side BC or CB. All right? So then the second point here is really, really important for problem solving. So I'm even going to circle this because you'll definitely want to make sure that you drill down on this. So the interior angles of a triangle all add up to 180 degrees. So you might be sitting there as you watch this video listening to me. You might be saying, well, what in the world? What's an interior angle? I don't know what that is. Help me out here. So let me tell you, an interior angle, well, first of all, a triangle is a three-sided closed shape. And it's a closed shape because, well, it looks closed, right? It's not opened. So it's going to have interior angles. There's an interior angle here, there's an interior angle here, and an interior angle right here. Okay, and so that's what these little squiggly lines, that just shows you where the angles are in the triangle. Okay, and so the important point is that if you add these all up, okay, they're going to add to 180 degrees. So let me write this out here. So if you take angle A and you add angle B, and then you add angle C, okay, the sum is going to be 180 degrees in all cases, all the time. So 180 degrees. Okay, and so the last point we're going to be looking at more in depth here, that's that triangles can be classified by their side lengths and angles, so we're going to look at that now. Okay, so we're going to look now at how to classify triangles by length, and then we're going to look at how to do it by their angles. Okay, so the first kind of triangle that you can classify by length is the equilateral triangle, which is what we see on the screen here. And there's really only 2 points to know. First is that all of the sides are the same lengths. That's what these little black lines tell us. Whenever you see those, they're just telling you that sides are of the same length. And we also need to note that all of the internal angles are the same measurement, and they're all 60 degrees. Okay, so we see all of these internal angles, and they're all a measure of 60 degrees. So that's the equilateral triangle. Let's move on now to the isosceles triangle. So you're probably saying to yourself right now, why does he have a picture of two bicycles on the screen? Well, if you think about it here, and if you get really creative, iso kind of rhymes with bicycle. Okay, not really, but we can think of it that way to help you remember it. A bicycle has two wheels. Iso, Isosceles triangle has two sides that are equal in length. Bicycle, iso, two wheels, two sides equal in length. Okay, maybe it's a little bit of a stretch, but hopefully this helps you remember the isosceles triangle. Okay, so you can see on the screen an isosceles triangle, and we can see that I wasn't lying. I was telling the truth. The two sides of the isosceles triangle are the same length, which is the first point to note about the isosceles triangle. The second point is that the angles that are opposite from the equal sides are equal in measure. So what I mean by that is, so if we look at this side of the triangle here, which I'm going to highlight in blue, so we see the little lines here indicating that this side is equal in length to this side. And so if we look diagonally across from that side, we see an angle here. And so what we also need to note is that if we go to the other equal side and we look at the angle diagonally across from it, we want to note that these two angles are going to be equal in measure. So for example, let's say if this angle is 40 degrees, this angle is also going to be 40 degrees. So that's the isosceles triangle. So the last triangle that we want to classify by length is the scalene. And the scalene triangle can be summed up in three simple words, right? Nothing is equal. With a scalene triangle, nothing is equal. Again, with a scalene triangle, nothing is equal. Hopefully you're getting the point. Nothing is equal with the scalene triangle. The sides are not equal. The angles are not equal. We've got nothing is equal for our scalene triangle. Okay, so now what I'm going to show you is a quick way to remember the equilateral triangle, the isosceles and the scalene, how to tell them apart quickly. What you can also do, though, if you don't want to use this trick, you can just remember them. You can add these to your notes, and you can just, the traditional way, just memorize them from your notes, or you can use a trick, whatever helps. So let me get into that now. Okay, so here's a cool trick that I learned from mathisfun.com, and I'll put a link down there. They've got a cool information about triangles that's helpful, but the trick is really helpful, and I call it the alphabet trick. And so the way it works is you want to put equilateral, isosceles, and scalene in alphabetical order. So in alphabetical order, we know that E, then I, then S is how we would write this, right? And so then we want to remember 3, 2, none. Okay, instead of 3, 2, 1 like you normally count back, just remember 3, 2, none, or 0. So we put them in alphabetical order, and then 3, 2, none. Meaning that with the equilateral triangle, there are 3 equal sides and 3 equal angles. With the isosceles triangle, there's 2 equal sides and 2 equal angles. And for the scalene, there's 0, or there's none, no equal sides, no equal angles. So that's what I call the alphabet trick. And again, I'll put that link down there. You can read about that on mathisfun.com. So another way you can do it for isosceles is if you celebrate Christmas, if you look at the isosceles triangle, it looks like kind of like a Christmas tree, right? If you really use your imagination. And so you can sing the song, "Oh Christmas Tree," okay, but only you could sing it instead of saying, "Oh Christmas Tree, oh Christmas Tree." Okay, I'm not going to sing it on camera, although I'm sure that would be very entertaining probably at my expense. But you could sing it like isosceles, isosceles, 2 angles have equal degrees. Isosceles, isosceles, you look just like a Christmas tree. Okay, and you would sing that in you would sing that to the song, "Oh Christmas Tree, oh Christmas Tree." Okay, again, I'm not going to sing it, but you can use that as a way to remember it. Okay, and so you can also, another way to remember it, this is kind of dumb, but it helps. Often the dumbest ways to remember things are what make it stick the most. So if you look at the first 3 letters here of scalene, okay, it's the same 3 letters as the word scary, right? So scalene, the sound is the SCA, so scalene, scary. Scalene is the scariest triangle because none of the sides are equal. There's no equality at all with the sides or the lengths. So you can remember it that way if that works for you. But this is a cool trick, and there's some other ways to remember it too. So most importantly is to find what works for you. And as always, if you don't like any of these tricks, you can just memorize them the old-fashioned way, right? Put them in your notes, just memorize them, just repetition, spaced repetition. And so now we're going to look at how to classify angles by measurement. Before we go on, if you found anything in this video helpful, go ahead and let me know by hitting that like button. Thanks a lot. Okay, so we're now at one of the most important triangles in the whole video. This might be the most important type of triangle. This is the right triangle. So make sure that, if nothing else that you take away from this video, you remember what a right triangle looks like. Okay, so it's really easy to recognize. All you have to do is look for this little thing, this little square that I think it looks like a box. I call it a little box type thing. You can call it whatever you want. But you want to look for that little square, that little box, okay, in the corner. What that is that tells you that it's a 90-degree angle. And that tells you that you've got a right triangle, okay? So now I want you to look at this line here. So focus on this line, okay, and focus on this line going this way now. Okay, so see how they intersect right here. Okay, they intersect and they create that 90-degree angle. Okay, what type of line is that? Okay, if you haven't learned this yet, that's fine. I'm going to tell you right now. Whenever you have two lines that intersect and create a 90-degree angle, they're called perpendicular lines. So we've got perpendicular lines going on right here. So again, whenever two lines intersect and create a 90-degree angle, those lines are said to be perpendicular lines. Okay, so I'm going to clear that junk out of there, and I really want to drive home that whenever you see this little box type thing or this little square, whatever you want to call it, that tells you that there's a 90-degree angle. So again, 90-degree angle, little box type thing, right triangle. Okay, I'm going to say it probably 1,000 times. Hopefully, you're going to get tired of me saying it. I'm getting tired of saying it myself, but I really want to drive that home, that 90-degree angle and the little box type thing tell you that you've got a right triangle. Okay, so the little box type thing, 90-degree angle, right triangle. Okay, hopefully you got it. Okay, so, and the reason that this is so important is that you can use the Pythagorean theorem to solve problems. So, you might be thinking, Pythagorean theorem, what's that? It might sound like I'm speaking Greek. Well, actually, I am speaking Greek, because Pythagorean, it is a Greek term. It comes from Pythagoras, who was an ancient Greek philosopher and mathematician. Okay, but that's beside the point. The point here is that you'll want to know how to use the Pythagorean theorem. So I filmed a whole other video on that is really helpful to help you clarify how to do that. You'll definitely want to watch that because that's very important for your test. But I'm just going to show you how it works here basically. So we can call this side of the triangle side A. We can call this side of the triangle angle B. This side of the triangle is side B. And this side of the triangle is side C. Okay, and so there's a mathematical relationship where we can say that a squared plus b squared is equal to c squared. Okay, and this is very important, okay, because you might be given a problem where they give you the value of b and they tell you what c is and they ask you to find a. Okay, or they might give you the length of, say, side A and the length of side B, and they want you to find the length of side C. Okay, so if this is important for problem solving, like I said, I'll post a link to that video that should help clear this up for you, but this is something that you're going to want to know. I'm not going to get too much more into the Pythagorean theorem here in this video. I just wanted to mention it. That's part of the reason why right triangles are so important to be able to recognize, because you're probably, not always, some people don't, but a lot of people do. Depending on what version of the GED test you get, there's a good chance that you'll get a question with a right triangle. Maybe not, don't know what version of the test you're going to get, but there's a good chance. So file this away in the back of your mind and check out that video if you want to. Why did I just show you a video of a cute little baby? Why did I show you a cute little baby? Well, because we're talking about acute triangles now. And that's an easy way to remember it, is that acute triangles have angles that are less than 90 degrees. Okay, so in geometry, an angle that's less than 90 degrees is an acute angle. It's a cute little angle. Okay, that's the way that my math teacher in middle school said to remember. You think of it like a little baby. You go, a cute little angle, a cute little baby. Get it? Hopefully you get it, okay? It left an impression on me. Hopefully it leaves an impression on you. But an acute triangle, all of the angles are less than 90 degrees. So all of the angles are acute angles. An acute angle is an angle that's less than 90 degrees. So an acute triangle has 3 acute angles. Okay, and acute angles are angles that are less than 90 degrees. So an acute triangle has 3 angles that each measure to be less than 90 degrees. Creative again, and let's imagine that triangles are like people and that triangles can eat. What's going to happen if you feed a triangle nothing but burgers and french fries, fast food and soda for a year. What's going to happen to it? All right, well, it's probably going to blow up, okay, or it's going to become obtuse. So an obtuse triangle is a triangle where one angle is greater than 90 degrees, okay? So now we've just looked at the three different types of triangles that you can classify by angle measures for the GED math section. That was your right triangle, and you remember the right triangle because you're going to look for that little box type thing or that little square in the corner. It tells you that that's a 90-degree angle and that you've got a right triangle. And you're going to remember the acute triangle because you remember that. You're going to remember that video of that baby I showed you, right? Whenever you see a cute little baby, you go, oh wow, isn't that a cute little baby? So when you see a triangle that all three angles are less than 90 degrees, you're going to say, hey, that's an acute triangle. And then when you see a triangle with an angle that's greater than 90 degrees, okay, you're going to remember that that's an obtuse triangle, okay? So you remember that because if the triangle eats nothing but fast food for a couple years, it's going to blow up and become obtuse. One of the angles will become obtuse. The angle is greater than 90 degrees. Okay, so definitely remember this stuff. Remember how to classify triangles by their angle measurements and how to do it by length, because you can see you might get, there's all kinds of different variations of questions that they can ask you. So we're going to move on now, and I'm going to show you an example or two here, and then we're going to call it a wrap. So thanks for joining with me so far. We're going to look at some examples, and then we're going to wrap it up. Okay, so this is our first example problem, and I want to hop off the camera here so you guys have room to see kind of a word bank that I made over here. And the problem is to classify the triangle by both side length and angle measure. So we see a triangle here. We see one 80-degree angle that's labeled. We see that one side of the triangle is side length 12. We see another side that's of length 12 and another side that's length 35. So go ahead, pause the video if you want to, and try this on your own. Okay, so hopefully you just had a chance to try this. And so we're going to go over how to do it. So we want to classify it by side length and by angle. So for side length, let's start there. So first of all, for it to be an equilateral triangle, how many side lengths have to be equal? Well, we need all three to be equal, right? A triangle has three sides. In an equilateral triangle, all three of those sides are the same length. And since in this triangle, we know that we have 12, 12, and 35, so only 2 out of the 3 sides are the same length. So we know that this is not going to be equilateral, so let's get that off of our list here. So for isosceles, we remember that bicycle has 2 sides, right? A bicycle has 2 wheels. So for an isosceles triangle, there's going to be 2 sides that are the same length. And so we see that we've got a side length 12, a side that's length 12, 2 sides that are the same length. So this is going to be an isosceles triangle. Okay, and so just to review scaling, none of the sides are the same. None of the angles are the same. So now let's do this by angle. So what we want to look at here is we want to see that one angle is less than 90 degrees, okay? So it's an acute little angle. An angle that's less than 90 degrees is an acute angle. So if a triangle has an acute angle, it's therefore an acute triangle. So we can jump right in here to acute. We know it's not a right triangle because we don't see any angles that are 90 degrees. We don't see that little box type thing, and that's got to be there to be a 90-degree triangle. And we see that it's not obtuse because this one angle is less than 90 degrees. So just as a quick recap here, if one of the angles is less than 90 degrees, then it's automatically acute. If one of the angles is greater than obtuse, it's automatically an obtuse triangle. Okay, so hopefully you understood that one. So this is another great example here, and what we're going to do is I want you to find the measure of the missing angles. This is the same exact triangle here. We just see that we see 2 question marks because we don't know what these 2 angles are, so go ahead and try to find them on your own. Okay, hopefully you had a chance to do that. But what we really have to understand to solve this problem, as we're going to go over it, is so we already know that it's an isosceles triangle. And so for an isosceles triangle, 2 of those sides are equal in length. And the 2 angles that are opposite these sides are equal. So what we see here is for this side of the triangle, okay, we note that this angle is opposite. And for this side, we note that this angle is opposite, okay? But the key is that these 2 angles that I'm going to circle here, the 2 angles that we're trying to find are equal in measure, Okay, let me clear that junk out of here. So the two angles that we're trying to find are equal in measure. And so if you got stuck on this problem, let me give you an equation here to kind of help you remember this. So all three of the angles in the triangle are going to have to be equal to 180. So these interior angles add up to 180. So we can make an equation here. So we can take the angle that we know, which is 80, okay? And since, let's call these x. So for the two angles that we don't know, I have question marks here. Let me cross those out. We're just going to call them x. Since we don't know what these are, we're going to call them x. So all the angles add up to 180. So the equation is going to be 80 plus x plus x equals 180 degrees. But I'm not going to write the degrees, but just know that I mean 180 degrees. Okay, and how did I get that? Well, I took 80 from the value of the angle that was given to us. Okay, I just plugged that into the formula, and then I took the x's and I plugged these x's right up into the formula. And again, the formula, the reason that we can make the formula is because all of the interior angles of the triangle add up to 180 degrees. Okay, let me clear that out here so we've got some room to work. So we can do a simplification here. All right, so we've got x plus x. And if you take x, add it to x, you get 2x. So we've got 80 plus 2x equals 180. Okay? And so hopefully you're familiar with how to solve equations. If not, I have a video about that I'll link to down below. So what we would want to do, though, is we want to isolate the variable. So we've got this 2x here. We want to get that x by itself on the left-hand side of the equation. So we're going to do the opposite or the reciprocal operation. So we have this positive 80 out here. We want to get it off of the left-hand side of the equation. So we subtract 80 from this side, and 80 minus 80 is 0. Then whatever you do to one side, you've got to do to the other. So we're going to also subtract 80 from this side. So then we rewrite the equation. We've got 2x equals 100 because 180 minus 80 is 100. Okay, so now what we want to do is we want to get rid of the 2. So we've got the x by itself on the left-hand side of the equation. So we've got 2x, which is essentially 2 multiplied by x. So since 2 is multiplied by x, we want to do the opposite operation. So the opposite, also called the reciprocal operation of multiplication, is division. So to get rid of that 2, we want to divide by 2. And whatever you do to one side, you also want to do to the other. So we've got 2x. 2 divided by 2 is 1. Cross that out. 1 times x is just x, so we can leave that. 100 divided by 2 is 50. So we see x equals 50. Okay? So we now know that for each angle, okay, x is going to be equal to 50. So each of these angles is going to be 50 degrees. And if you want to check it, just to make sure, all you have to do is you would just add up all the angles and see if they equal 180. So we've got 80, okay, plus 50, plus 50. And you can do it with a calculator or do it in your head. Just note that 50 plus 50 is 100. 100 plus 80 is 180. So we're good. The example works out. So we made it to the last example. And this question is, in triangle ABC, angle A measures 74 degrees and angle B measures 12 degrees. What is the measure of angle C? So as always, you know the drill. Pause the video, try it on your own if you'd like to. Okay, so hopefully you are seeing that what you have to do here is write an equation. And the equation is that angle A plus angle B plus angle C equal 180 degrees. Okay, and so we know that for any type of triangle, no matter what it is, all of the internal angles are going to add up to 180 degrees. And so in this case, we're given the measure of angle A as 74 degrees, and we know that B is 12 degrees. Okay, but we don't know C, so I'm just going to leave that as C. Okay, and we'll set this equal to 180. Okay, so now what we're going to do is we can add these up. So what's 74 plus 12? 74 plus 12 is going to be, well, I'll write that out over here. So 74 plus 12, we get 86. Okay, and so then we're going to have 86 plus C equals 180. And so now what we're going to do is we want to get the C by itself. So what we do is we subtract 86 from both sides of the equation. Okay, and so how do we do this math over here? Okay, so what we're going to do is we see that 0 is less than 6, so we're going to have to borrow. So we cross out this 8 and we borrow 1, so we turn that into a 7. We make this a 10. Okay, so now we can subtract. So 10 minus 6 is 4. 7 minus 8. Well, we see that 7 is smaller than 8. So what we've got to do is we've got to cross out this 1. We're going to borrow from it. Okay, and we're going to then cross out. Okay, so then we borrow that 1. And so then we are going to make that 17. All right, and so how do we get, so what is 8 minus 17? Or I should say 17 minus 8. Well, it's going to be 9. So we're left with 94. So angle C is equal to 94. Okay, so how do we check this? Well, let's go back. So we know that A plus B plus C should give us 180. Okay, so let me just write this out here. So we already know that 74 plus 12 gives us 86. So 94 plus 86 should give us 180. Okay, so 4 plus 6 is 10. So I put the 0 down here. We're going to carry the 1. 9 plus 1 is going to be 10. 10 plus 8 is 18. So we write the 18 here, and we got 180, so we're done. That's the correct answer. So the correct answer is that angle C is equal to 94 degrees. Okay, so that's the video. Let me know if you have any questions about anything. Good luck with your test studying. Thanks for watching.